Hey again everybody. Alright, we're in our second video for section 6.2, using proportions to solve geometry problems. And we're going to do something that's kind of common sense to you as far as why you would need to be able to do this, I believe. We're going to solve problems involving scale drawings, which are very useful things. And you'll kind of see that as we go through a couple of examples. Of course, scale drawings can be used for lots of different things. Architects use them all the time, engineers use them all the time. They're used to make models, toys, whatever in the world. Here I have a scale drawing of the Eiffel Tower, and the problem says that the width of the base of the Eiffel Tower, the actual thing, is 125 meters. It wants us to use a scale drawing to find out what its height is. Alright, now on our scale drawing, it is 2.5 centimeters. The base is, that's how wide it is. And in real life, the actual Eiffel Tower's base is 125 meters. What we're going to have to do in order to find out the actual height of the tower, knowing what the height of the drawing is we're going to have to find out what's called the scale factor. And the scale factor is simply the ratio between the dimensions of the actual Eiffel Tower and that of the drawing. So we're trying to make a ratio of the Eiffel Tower to the drawing. And so proportions are going to be used to do this. And this is very simple. What we can say is that if there's 125 meters for the base of the actual tower, and I compare that with 2.5 centimeters, alright, this is the ratio of the bases right here, then I ought to be able to make a ratio between the height of the actual tower and the model, and those two should be proportional to one another. So the height in x meters of the actual tower would correspond with 6.5 centimeters on the drawing. Now I only put the units here so that you can see I've got meters to centimeters in both ratios. I don't actually have to worry about the units in my actual calculations. All I've got to do in my actual calculations is cross multiply, because this is a proportion that I'm solving, and the units will take care of themselves because I've got consistent units in both ratios that I've made. So I'm going to say then that 2.5 times x, which is the product of the means, equals the product of the extremes. 125 times 6.5 is 812.5. And then we can go ahead and divide by 2.5. We're going to find out that x is 325, meaning that the tower, Eiffel Tower, is 325 meters tall. Now probably that one example is enough for you to see how we use scale drawings. Just in case, I do have one more example here on a map, and obviously maps then are another place where scale and scale factors are quite useful to us. And I've got a map of the state of Texas. And you'll see in the bottom right-hand side of that picture the scale on the map. It says every half inch on the map is 50 miles. And what I've shown you then is that the distance from Austin to Dallas on the map is 1.9 inches. Okay, anytime you see a distance on a diagram and it's got those little quote marks right there, those quote marks represent inches. There's 1.9 inches from Dallas to Austin on the map. Now, I'm going to use the same idea where I'm going to make a ratio of Dallas to Austin, which actually wouldn't make a lot of sense. What I mean to say is I'm going to make a ratio between the dimensions on the map and the dimensions in real life. Okay, so my real life to map ratio. And so in real life, 50 miles is 0.5 inches on the map, correct? So, in real life, how many miles would it be if on the map there are 1.9 inches? See how that worked out? Alright, so the ratio between the real life and the map, that's our scale factor, essentially. Okay. So we can cross multiply, use our proportion here, we'll get 0.5x equals 95. I'm ignoring the units again because I've got consistent units in both my ratios, miles to inches on both of them. So automatically, whatever I get for x will be in miles. And then if you divide by 0.5, you're going to get x equals 190. So it's about 190 miles from Dallas to Austin. That's a quick crash course on using scale drawings. And really the larger idea, again, is how do you use proportions to solve geometry problems. Thanks for watching, guys. See ya.